Welcome to ET Auto in association with Siemens Roundtable series on future of R&D and manufacturing in Indian automotive industry. Today's topic is evaluating alternative to drive innovations in product and design in automotive industry. Let me introduce to you today's distinguished guest that is present today, Mr. Purushottam Panda. He is Executive Director, Powertrain Maruti Suzuki India. We have Mr. Chulanga Punda, who is Chief Information Officer, Daimler Commercial Vehicles India. We are also joined by Mr. Yuji Yamamoto, who is Chief Technology Officer, Sanden Vikas. We also have Mr. Vivek Kumar Jakhmola, who is Senior Vice President and Domain Head for body emission trim at Lumax. Lumax is one of the technology-driven auto component company in India. We are also joined by Mr. Murli Lakshmi Narasimhan, who is head of pre-sales at Siemens Digital Industries. Welcome to ET Auto Roundtable, gentlemen. We are really glad to host such a luminaries from the automotive R&D and design space. And we'll open the session with your initial comment or submission on the topic for the day. What are the alternative, options in such a scenario of COVID where, we have seen everything has moved out from the fixed setup that we had inside a plant or inside the office. Now many of us are working from home. Is it possible that the R&D or the product design and development can come to the ease of your home? Is it possible? And what are the alternative innovation that we have to think that could drive the next phase of design and development in automotive industry? I'd first invite Mr. Panda to open the session with his remark on this subject.
The vehicles have become very, very complex nowadays. Remember, as a kid, I used to drive in a village jeep in the jungles of Odisha, and when it used to rain over there, we used to just reach up and turn a lever, and the wiper used to function. It was done manually. Similarly, when I joined Maruti about 85, electronics one was coming into the cars at that time. So from mechanical, we moved to electronics, and now is the age when computers are getting into the car. So what you are seeing is nowadays you have about 20 to 30 ECUs in any car that you see nowadays. And if you look at computers, one thing comes to mind. They have, say, ordinary PC. We'll have about 40, about how many? 40, about 40 million lines of code. And for every 1,000 lines, it's a typical industry norm that you have errors which are how many? About uh, 10 to 20 errors every 1,000 lines. So you can imagine how many errors you have in one PC. So every ECU in a car is like a 1/5 or 1/6 of a computer. So 20 such things basically mean that you are having almost 100,000 errors in this code that you have in your car. So there are so many things which can go wrong. So how do you get all these things to be done right, especially when you are having a very challenging environment where you are, say, restricted from being physically available? It is very, very, very difficult. Uh, I remember about 10, 15 years back, we used to have about 30% of our, what do you call, development was more related to computers and related to software, and 70% was our hard development. Nowadays, we are at an age where we can do 50% physical development, 50% soft development. So still, we have a long way to go before we can actually do justice to developing vehicles which are of the right quality, of the right, what you call, requirement that a customer wants. completely remotely. There are big challenges, and I'm sure that my co-panelists here, they will have stories to tell about what kind of challenges they foresee under the present circumstances. That's all from me. I will come in between later on.
Thank you. Thank you, Mr. Panda. So, evaluating the alternative to drive innovation in times like this, when we everything has whatever we had normal has become something that cannot be attained right now. We are living in a new normal. So, in a new normal, what are the alternative that could drive the innovation, especially to product design and development? Vivek, I would like to bring you in here. You are tier one suppliers, and along with the OEMs, you have to carry the innovation. You have to be part of the innovation or the next set of products that are going to come. How are you working? How are you coping up with the kind of transition that is taking place? How are you going to meet the expansion in the production that is going to take place once we open up?
There is a lot of changes which has happened in many decades. Uh, I was just going through one of the readings where we in 1950 we started first time some electronics uses in the vehicle, and it took us about now 70-75 years to reach to 30-35% level of electronics in the vehicle. But now whatever innovations we are working upon, we are sure that next 30% will come in less than 10 years. So soon we will be more than 50-60% electronics and software portion in the every car value wise. There are a lot of innovations which are not only for the sake of innovation, but for the sake of survivability and for the sake of new regulations which are coming in from the government. And OEMs are, of course, taking lead in this, but it's a responsibility of tier one companies also to propose many innovations. So at Lumax per se, we are quite proactive in this. We have our own new technology group. We have the R&D centers who are working on the future technologies. Uh, Recently, this COVID-19 situation, as you said, that how we are going to tackle it later on. Recently, not only us, but there are many tier one companies. We are talking about addition of in requirement of innovations. जैसे आवश्यकता आविष्कार की जननी होती है. So there, a lot of safety related innovations, and this safety, I would not say that only it's a passenger safety or the vehicle safety, but lot of innovation in terms of now health safety related innovations. We expect that those things will also be added in the vehicles. So I'm fully confident that going forward, innovations will have its own definition. It's a new definition. COVID-19 will change many things, and this will also give us a gift that we will have a wider area to innovate upon. So that's my take on today's topic and your question.
I would like to bring you in from the commercial vehicle perspective, Shalanga Prada. If you could give us a sense, what are the alternative, in this time that we can explore or evaluate to drive innovations? Quickly in 1 minute about.
If you look at commercial vehicles per se, I mean, globally, even in Daimler, we've been trying to work across different borders, specifically in autonomous driving, in electrification. And I think this COVID scenario has sort of enforced us to adapt and embrace those changes very quickly. And these drives have to come from different boundaries. The situation in NAFTA will be very different from Europe to Japan to India. And we've realized that, distance is not a barrier. There are a lot of technologies that we can sort of embrace, augmented reality, virtual reality, and really get different talents from different parts of the world who have different experiences, who are adapted to different local conditions, come together to expedite the growth of innovation when it comes to autonomous specifically, and when it comes to, for example, electrification. So I think from a product engineering, from an R&D perspective, we have come to realize that not being co-located is not a barrier. And I agree with our colleagues who have just expressed their sentiments and emotions about the current situation, that it will expedite innovation very rapidly. And I think that is one very important aspect we've come to realize very quickly.
Usually, you have been in the industry for over 4 decades now. You have seen several challenges that the industry has faced and they have overcome. Looking at the current scenario, how do you look at the topic that we have today? If you could give a sense, what are the alternative way of driving innovation in times like this when we are in a lockdown situation and even we can work with only 33% of the workforce, and that too looks a distant dream because looking at the current situation, we are really not able to match even 15-20% of the production capacity.
Yeah, even 4 decade career, it was my first time. It's my first time such a COVID situation. Really, remote working. But maybe in a sense, so our team with my team, I had the highest productivity for the innovation. So in this period, we already drafted 3 patents, myself also involved. So really, we can think about something innovative solution. So more and more software algorithm side. So we are working on this area. 41 years I'm working for thermal system, always, not only current company. Yeah, Prana Vikas, Sanden Vikas. So it's a really the chance. Challenge is a test and prototyping. This is still challenge, but maybe this will lead us for the automation testing, automated monitoring, etc. This will bring us another innovation, I believe.
I would like to bring in now Murli, who is head of pre-sales at Siemens. Murli, you work with the entire value chain and any kind of future technology innovation that is to be started. Probably you guys are the people who start supporting OEMs, components, and other part of the value chain. Looking at the current situation, what kind of you know demand or what kind of trend you are noticing from the automotive manufacturing side or the design side or the what are the innovation that people are thinking? What is the focus of these manufacturers or R&D people right now?
Like they say, in this kind of times, cash is king. So, I think one of the panelists said that it is out of necessity that, we need to focus on efficiency and effectiveness. So quickly, I will just talk about 5 trends that we hear from OEMs as well as suppliers. The first one is there is a lot because of the work from home, remote working, and other functionality as well. And keeping the efficiency and effectiveness in mind. The first thing is we see a integrated program planning, because people are, in diverse places. The ability to, follow the stage gate process where you're taking care of the compliance and traceability as well. Front load the programs, and therefore there is a need for us to track that. Number one. Second thing that we look at, as some of the panelists mentioned that quickly, I will just touch upon that. There is a feedback need, a lot of feedback need because of people working remotely and a close looping, if I make it feel well. Chulunga also mentioned about the electrification and autonomous programs. Products are anyway getting smarter, so that's given. And I think Vivek also mentioned that, as well as Panasan on the electrical, electronic, and software. So there is a ALM, PLM, and mechatronics. We see that as the second thing. Third, that we also hear not only from automotive industry, of course, this roundtable is in the automotive industry. The leveraging of the augmented reality and virtual reality for high definition product, that is taken advantage of later in the workforce in training. Number 4, I think Vivek touched upon it, alluded to it. OEMs working with suppliers, different levels of engagement, print to print, component supplier, system supplier, and so on. So that supplier collaboration is a third area that we see. To summarize 2 more points. These times, as opposed to a physical testing where there is, we talk about social distancing and so on. There is a lot of focus on virtual validation where there is, you do a lot of post simulation and, few places where the actual product usage is taken through IoT. So that is an interesting IoT. Fourth pillar that I would say is looking at the quality. How do I look at the quality? Because as I said, cash is a king, whether it is OEMs or suppliers. So the rework reduction and rejection cost. So therefore, need for virtually validating the manufacturing and assembly and being able to take that data. Last but not least, I think we hear from not only automotive but across the board. With this remote working, data security, the IP protection is extremely important, and this is something that we have heard. There is a lot for need for working together with the employees. While there is a need to share, there is also a need to protect. So these are quick summary that I would say.
Mr. Panda, I would like to bring you in here. So let's steer the discussion towards current situation. And in current situation, how do we maintain continuity of our work? And today our topic is about product design and development and R&D. In current scenario, when a huge section of your workforce is at home, so what are the processes, what are the elements, or what are the technology we can implement to maintain continuity of the work from remote in R&D and product design and development? How are you leveraging the current situation? Which are the technology or what are the means and ways you are using to maintain that continuity of your team on the work, the project that you were working on?
As I was saying, it's quite a challenging time. I think all of us are facing this particular situation. At Maruti, we always thinking from the customer point of view. So whatever that we do, we want to make sure that the quality of the product and the quality of the service that we offer matches with the requirement of the customer. So for doing that, we have to ensure lot of what you call checks and balances in place when we do anything. So similarly, when we had this sudden lockdown in the country, much needed, of course, and hats off to all the medical fraternity and all the day-to-day support staff who have been making our life livable. We what we did was we started seeing how we can rapidly scale back and start doing things in a way which is possible. One of the factors I'm sure that all of us know is for risk mitigation is multiple location or co-location. So one way to do this was to spread out our what we call development from the office to other than office. Then slowly to areas where we could sit together and yet do work from multiple places, because you need to have, automotive is a traditional industry, all said and done. So you need certain touch and feel. So while doing in this way, you can digitize the development process to a large extent, because you have to think from the customer point of view and take care of all the requirements of quality, performance, etc. the customer has. You still have to rely on physical work and physical testing, physical validations. So as I mentioned, a lot of electronics is coming into the car. This is both an opportunity and a problem. Opportunity in the sense that you can use a lot of digital means to catch these problems. Okay, and an issue because there are these problems you cannot catch by digital means, so you have to do physical work. So right now, I will say that as an automotive industry, worldwide, perhaps we are somewhere about 50-50 to 70-30. That means we rely 50% on virtual validations and 50% on physical validations. And some of the best practices go up to say 70% virtual validation and 30% physical validation. We have not come anywhere near 100, 0 or 90, 10. where you can say that you will validate everything perfectly in the virtual way. So for that, we have to find special solutions how to do this.
So you think validation and testing is one area where we are not able to achieve 100% or come closer to even 90%? Looking at the current situation, do you think it will trigger the people in this space to look at opportunity or alternative innovations that we can reach at least 80-90%? Or what is your assessment? Where the focus of technocrats in design and development or R&D like yourself is right now?
I'll give you a small example. Nowadays, you populate the office and your workplace with, say, 30% manpower to 40% manpower to keep social distancing, right? So, when you are doing such kind of work, you can always innovate and have areas that one person does a test, goes back home, and he does his analysis. Okay, the second thing is person does a test, someone else does the analysis remotely. So that way you can create this social distance. This is a kind of innovation, and all of us, I am sure, are learning from each other. I'll be very happy to hear from my co-panelists what are the other innovations they are thinking of in these situations so that we can also learn and apply across the industry.
Uh, okay, thank you, Mr. Panda. I'll go to Mr. Pereira. Mr. Pereira, you are the CIO of Jakhmola in Commercial Vehicle India. You have a lot of exposure to the world manufacturing processes and all. And your group company has done a lot of innovations in terms of manufacturing, and others have also done it. Now, looking at the reduction in the manpower, as Mr. Panda, just mentioned, how are you trying to reduce the impact? Because with the social distancing coming up, a lot of time is required to maintain the sanitization protocol also at the shop floor, the plant level. What are the technology, intervention are you doing, or are you thinking to implement to reduce that impact? Because this will further increase the cost if the sanitization protocol takes that much of time. How can we manage the productivity of the people that are coming on the floor right now?
We have started to assess what actually makes sense. Implementing technology for the sake of implementing, like you said, can add on to additional cost. It can overburden the people as well, and it can disrupt the ecosystem with which we work. And therefore, what we have done is we have tried to categorize our opportunities, look at the advantages and disadvantages. So, for example, an investment we had to make was further VDI, right? To enable all our R&D colleagues, everyone across the organization to work from home. But that also has implication. For example, once we set up VDI stations, the rent we pay for additional manpower can be reduced drastically, right? And then also commute time. Now we live in metropolitan cities, our employees, the travel time drastically reduces and their efficiency increases. But like Mr. Panda mentioned, you also compromise on physical quality checks and balance. The other opportunity that we also look at is if you see, for example, agile development that we all talk, it is very hypothetical and theoretical, but implementation in large organizations take a lot of time. If you look at DevOps, if you look at an open source, right? These were norms that we looked at from a theoretical, but from a practical term, it became very difficult to implement. And this was the time we said we need to invest more. Agile development methodologies come in for new innovative ideas, and we can put this not just across R&D, it can be across all spectrum. One area we looked at is the increase of AGVs in our production line. Now manpower cannot go to the plant, so we have to be very specific about the 33% that is our minimum. So why can't we look at automating our warehouses and use AGVs to go and pick up these things and come back? These are opportunities which can be done very, very quickly, but it has to make sense and it has to be very business focused. And I think this is where you will see the automotive sector focus a lot more going forward.
Automation is, but frugal automation that will work in India, because in India you have manpower cost is still much lower compared to Europe, so or the developed nations. So investing in autonomous. How open are you guys to invest in autonomous in India, or in terms of automating your processes like shop floor, conveyor belt? We see he talked about AGVs. How can we? But we go abroad, we see a lot of robots working, but in India it is still less. On every 1,000 people, number of robots are much lesser than the developed nation. So how do you see this balance between the cost of manufacturing and the automation that we can adopt? Vivek and Yuji, you can also join in and answer this briefly. We'll start with Panda Ji first. India has a very competitive manpower cost. Means, almost 1:5 ratio when you compare with Europe and India, or a developed nation versus India. So Indian industry, or specifically automotive industry, did not have the habit of adopting automation that much. So in current scenario, do you see that people now leaning towards automation?
Certainly. See, Maruti also, we have slowly been automating many of our processes. The need for automation is not just to control the cost, or having manual is not only for having cost.
Oh,
You
efficiency.
should understand that. Hello, can you hear me?
Yeah. Yes.
So, what you got to understand is that whatever process that you want to follow, it has to meet the requirements of the market, of the customer, and the process which is done should be safe, should be comfortable. These are the two things which will derive whether you want to automate a process or keep it manual. Cost difference between uh, other countries and our country, though I hear you mention it is 1/5, I think in the automotive industry it may not be so much. It may still be little, what do you call, the gap would have come down from what it was, say, 10, 20 years back. Today, the Indian industry competes not only in terms of providing lower cost labor, lower cost manpower. It also competes because our people are good at innovation, they are good at calculation, they are having a good engineering mindset. So, from that point of view, I think India has a potential to be a world player in any industry, not just based on cost of labor, but also based on the kind of subject or kind of expertise you bring to the table.
What is very important, Nabil, is also for us to understand that the infrastructure and the ecosystem has to match as well. If you look at India as a workforce, we have a very highly literate workforce in our hands, which means when we automate, we have to automate to enable them to become more efficient so that we can unearth more talent. There was always this norm that introducing BS6 would reduce pollution. It would not reduce the overall pollution as long as you have BS3, BS4 vehicles still running, right? So also automating or having autonomous vehicles or electric vehicles, even for us as a Daimler, the proven technology is there, but introducing that, does the country have the infrastructure? So when we talk about this whole automation perspective, you are right. When we look at even our shop floors, condition monitoring, it's easy to implement, but with the labor cost that we have and with the workforce we have, do we really need to do that, or can we live with a downtime of 2 hours? So as our volumes and production volumes increase for every industry, that is where automation comes in. And that is what will make a player successful if you know how to complement your existing workforce with automation.
So it's about the ecosystem and complementing the existing system. That's perfectly put. Yuji and Vivek, I
Yes.
have a specific question to you as a supplier. We see that with all the sanitization protocol coming up, and the cost of production is going to go up. And looking at the current situation, I'm I I'm reluctant to accept that OEMs are going to give you a pay hike of your or cost hike in your for your products. In such a scenario, it is how are you trying to manage your cost using technology or innovation?
So, thank you, Nabil. I think this is a very interesting question, and especially if asked in front of our customers like Tamil and Maruti. So it's a good chance
No,
for us.
I'll add to it that Maruti also, yeah,
Uh-huh.
same goes for Maruti also or any
Of
OEM
course.
also. But for you, it's B2B. For them, it's consumer. So it's for them even tougher to address this. Will go to them also. But now to you, how do you deal with
Absolutely right. So ultimately, the circle completes when I become a customer of my customer when I buy a
it?
car.
Yes, yes.
So I think one thing which we have to be very clear in our heads about is what is important nowadays. So in current situation, I think the most important asset which we have to take care of is our people. So right now, none of us probably, of course, as in the starting, one of my friends said that the cash is the king, and we have to take care of our financials, without which there is no meaning of doing any kind of a business in this world. But I think people safety is paramount, and these are the same people who are working for us and who are ensuring that while we remain safe and our factories remains moving, we continue to supply good quality products to our customers. If we compromise anyway on the safety of our people, people are going to remember it. And as a corporate responsibility also, it will be very adverse on any of the companies. So my take on this is that safety of the people, beyond a point we cannot weigh in terms of money or the cost which we are investing in. If we are able to provide right kind of a environment which is safe and our people have trust in it, I'm sure with the kind of frugal mindset, engineering mindset we have, and the kind of innovations we do, very low cost innovations we do in our factories, and as in Japanese they say it's a small kaizens we do. Those will ensure that we will reach to at least 90-95% of our efficiency with
What
these
is the
changes also.
what is that current focus? What are the two, three elements that you guys are focusing right now that you see that immediately can be changed or turned around to help you in terms of reducing the cost of production or design or development, whichever part of the business you are right now?
So, Nabil, basically what happens is that we at component manufacturing, we are very clear that we have to match the takt times. So whatever the speed the customer is pulling from us, all our expenses, all our resources has to be aligned to it. So we cannot say that I will make 100 parts in an hour, whereas my customer is expecting to supply only 25. So what happens? We reduce our number of manpower, and we change our SWCT charts, standard work combination tables, and we ensure that whatever resource we put in, be it electricity, be it air, be it manpower, it matches with the output required. That is the only way, and the companies who are successful in achieving it, they are able to control their variable costs in the same proportion that it should be, and while reducing their fixed cost as much as possible. If some company or some team is not able to match the output versus input, and input cost is higher, for sure, it's anybody's guess what is going to happen.
Yuji, your take on it.
Yeah. Yes, one of the question, how to cut R&D cost in this situation, such kind of, so, and also from Panda-san, so what is the innovation? Yeah, so I think there is no magic anyway. Yeah, but when we started this remote work, I explained to the people, please utilize the brain and please remove unnecessary stuff or not compulsory. So we can remove the not compulsory work or stuff. This will give us more efficiency. Yeah, and the time also saving. If we continue removing so-called Japanese muda, we can remove the muda.
Mother,
And
yeah,
so
noise.
yeah, so we can continue like this. Then after post COVID, we can be efficient. Yeah, this is what we are thinking. In fact, normally our company require original invoice to pay supplier of whoever, but currently we cannot do that. Then this process stopped. We can accept email, etc. So we don't need to go back to the paperwork, for example. Yeah, such kind of removing muda, this will create us, yeah, and also important things. So in India, labor is very cost competitive, but yeah, bank interest is very, very high. If we shorten the timing, development time, removing muda, so this will create um, happiness to the customer also. Yeah, our customer is a OEM, but eventually, yeah, final automotive mobile user also will be happy if we can reduce development time. This is what I'm thinking.
Thank you. Thank you. Murli, I would like to bring you in here. Mr. Panda also mentioned about how, validation and testing in terms of virtual world or virtually doing this process is still limited to 50-60% of virtual, and 40% is still needed to be done in real conditions. You guys are a sports system in this space, means company like yourself or the industry which you represent is supporting the industry for a long time. Looking at the current scenario, what is your view on this? How is it going to move? If you could give us a sense. Do you think it is going to move further in the coming few months or year? What is the work in progress in this direction to enhance virtual dependence when we talk about validation and testing of product or component?
Very interesting. That I think all the panelists expressed a very beautiful point where you said talk about cost reduction. So let me talk about it in two different aspects. Pandasan also mentioned about it, the virtual validation. Let's just talk about it for a minute. And I think these are very interrelated. The point of cost controls and so on. Since Yuji-san is there, let me also try my Japanese word pokayoke. I guess the waste elimination becomes really very relevant. I think in the current context. Why? And this is where when I opened, I spoke about integrated program planning to start with. But it sounds pretty down to earth and foundational. At this time, when we are looking at the programs, and to the point that Pandasan and Sundar also mentioned too, any work that we do, it needs to be properly be tracked. Meaning, any testing that we do, if we can ensure that the test that we do is really related to the program, because the labor is also, resource is also sort of constrained. So the time that we plan and execute them, it needs to be proper, number one. So the points that I'm making are based on this. So everything needs to be close to. What I mean by that is, you have a digital setup and a digital thing, as we call it. You digitalize the process to the point of we are not in a situation where we're going to eliminate the physical testing. It is needed, and I think Anderson mentioned that automotive needs that. There is no gainsaying that. But where are we moving? If you look at all the OEMs, whether it's in India or overseas, the approach is taking towards the system. For the suppliers as well, I will include them. It is what we call the model-based systems engineering, meaning right from what they call the front loading, right from the time the program is conceived. You want to keep the whole system lean. As far as the OEMs are concerned, and OEMs are very clear that they would like to take on a role of a system integrator rather than owning all the technology and developing all the technology themselves. And that's the reality, which I think is a right thing to do. So the suppliers also become part of this whole system, number one. So a model-based systems engineering where you front load the process and connect every work which is done by each of the team members in the design area, links up to the program, number one. And number two, one of the things that I see across all Indian OEMs specifically is there is a lot of compliance need, whether you are a tier one supplier, whether you are, a OEM. There's a lot of exports to different places, and the compliance needs are varying as well. So there is a need for compliance there. And I think Chunga mentioned about the traceability. I would build on that. So traceability, the product traceability as far as the processes. So that I think is key as far as the program is concerned. Now, when you talk about the efficient workforce and the simulation part, it's not as if we are doing the simulation now. It's fairly established, whether it's in automotive, aerospace, and so on. What are we trying to do? We are now trying to push it to the next level. And I'm alluding to both the OEM panelists' point of there is a bit of a physical testing as well. How do we do that? The sophistication obviously needs to change. It probably will get a little more complex than what it is. And this is where there are methods of what we call as post simulation. It's not as if we are not doing simulation, but the sophistication with which we do that, the inputs that we take to validate virtually these systems, what we call as a road load data acquisition in the typical automotive parlance. How do we improve that such that the duty cycles that the product works through is brought in virtually, number one. And number three, of course, I agree with one of the panelists' point of view that we don't do technology for the sake of technology. I don't think so. And I don't think as a country we compete on cost anymore. I think the intellectual power is there. So when we talk of IoT, it makes business sense, if it makes business sense, to bring the real product usage cycle into the design area as part of the virtual validation. I think that certainly would help us change and improve the proportion of how much virtual validation that. And number three, the interesting point that you said on how do we control cost from here. While on lighter vein, you did ask the tier one suppliers that they're not going to get any money from their OEMs and OEMs from the customers. It's a chain, I guess. But I guess every process step, if there is a waste elimination in terms of the process and the product process. So again, there are ways of virtually validating the manufacturing and assembly process, and process keeps changing with this product sophistication changes. We all go through design change, and therefore the processes also keep evolving. New technologies come, new product comes, so they evolve. And one of the other things that we also see with OEMs is now they want to look at bringing the test data, whether it is a prototype data, pilot production data, how can it enrich my design into, bringing into my quality. And again, I think, the conversations that we have had with some of the OEMs are on relating to CapEx. How do we manage the specifications on the product such that we are able to do more with less? So that I see are very key threats, Nabil, and I think
Thank you.
There are ways to get there.
Thank you, Murli. Thank you. Mr. Panda, I would like to bring you in here again. You are the center of the entire value chain, and probably you inspire the value chain to adopt automation, be it our digital tools, be it in manufacturing or in design and development. Now, you talked about we have been able to achieve 50-60% of the virtual, validation and testing. Can you give us a sense of the challenges that you face in further upping this, or is it the optimum that we can do, or which are the likely area or stages that we can further work in immediate term to go virtual?
Making cars and automotive industry is based on a build, test, break, build, test, break, build, test, make cycle. And that is where virtual validation comes in. It can reduce the number of cycles that we need to build, test, and break. So earlier, perhaps people used to build 5 times, 4 times, and then make it. Nowadays, we are perhaps at build 2 times, break 2 times, and make 1 time. Maybe in the future, we will be build build 2 times, break once, and make once. So that's how. And of course, the ideal situation is you build build it and doesn't break. But then how will you know that what you have designed is optimal if it does not break? So that is going to be the challenge. And as you mentioned, what are the areas that we need to up the game? The area that we need to up the game is if our prototypes have failed, if our say mass production parts have failed, and if this data can be flowed back correctly into virtual validation cycle, it will save a lot of iterations, it will save a lot of development costs, and in turn, overall cost in the value chain will come down. The profits, the customer, to the people who are involved in all across the chain will go up. So from that point of view, I feel that this is one area we should certainly look at. And as Pereira was saying, this is an era of electronics. I think Yamamoto-san and Vivek-san also were talking about innovations. The thing is that it is almost taken for granted that electronics will keep on increasing in our cars. The amount of programming will keep on going up. Amount of software will keep on going up. How do we keep it sane and how do we keep it reliable is going to be the challenge, and that is where uh, what do you call people across, whether it is OEMs, whether it is supplier partners, whether it is technology partners, all of us will have to come together and work to make this happen.
Thank you so much. I'll go to now Mr. Chulanga Pereira. You are CIO of a manufacturing company. You understand the challenges. Can you give us a sense, what are the key challenges that you face when using digital technology across, be it on manufacturing, be it on R&D side? And what are the solutions that you are working on in this direction? If you could give us a sense.
I think one of the biggest challenges we face is change management. One of the mentioned people is absolute key in this time. So adopting technology and these changes, it's not easy because we call it the new norm. And as simple as it may sound, sometimes it disrupts everybody. So if we don't have this change mechanism, and this is one of the biggest challenges we face, it becomes very hard for organizations to embrace technology or change. If you look at, we are now moving towards more analytics-based decision making. We have vast amount of data, so we try to make business decisions based out of that data. But somehow, one of the key challenges we face is the data is in abundance, but it's not clean data. And when your data is not clean, garbage in, garbage out, we face again a lot of issues. So I think one of the biggest challenges we face is not just change management and data, but also how do we make sure that people are trained well across every value stream to accept a digital or technology. Because for me, within technology or IT, I can bring in a lot of different innovative solutions, but people might not be able to embrace that in their day-to-day activities. And sometimes then it doesn't become efficient. You overload your existing underlying processes with more and more technology. And the last point for me is, how do we bring it all onto one platform? And then that is one of the biggest challenges I have, because for every problem, we start developing a small app here, a small digital solution here, an RPA bot there. But there is no unanimous, platform or sort of one common direction where it needs to be. And then this adds on to the complexities, your run cost, and then we become inefficient all over again. So I think these are some of the biggest challenges we are facing in today's day and age. And the fact that we are not face-to-face makes it even a bit more difficult. So I think if we can find the answers to these little questions, we become a little bit more successful than we already are.
Very rightly put. Now I'll come back to you, Mr. Panda, once again. The time to market a product, from conceiving a product to sending it to the market, has reduced drastically. In some cases, it is almost less than 2 years. It used to be 3 years, 2 years. Now even some products are rolled out in a year time. How do you see, and how are you managing technology, and how are you able to convince your suppliers? There are some small suppliers also So how are you dealing with these kind of fast, a life cycle of a product, and how are you using technology to enable that?
See, you cannot convince anyone, whether it's suppliers or partners or customers, unless they see benefit in what is happening. And one of the ways is there are, compared to the an era which was about, say, 30, 40 years back, the suppliers in India nowadays, they are very, very technically savvy. They are up to date. They know what is happening in the world, and so that is why they are able to. And in fact, many of them know more about the products than we do. They in fact support us in product development. So from that point of view, everyone knows what is at stake, what has to be. So that's why they also know that in order to hold customer interest, in order to what you call get a good response from the market, it is very much required to uh, put out new products in time, have shorter life cycles. So they have also innovated. All of us have innovated to make sure that we recover what you call the investments in time. The business keeps going, the customer keeps interested. I think that's the way the cycle runs. Um, uh, if anyone wants to add to this, please feel free. Vivek, I think you have something to say on this. I think
So,
Vivek's mic is off.
rightly said, sir. Basically, I think that uh, everything follows the business need. So, if the cars have to sell, and the trend is that every 6 months or every year, if a car maker is not launching a new model, then he lags behind, and the people have started going to the new models first. It is imperative that either the models have to be refreshed at a very high frequency, or you have to launch new models. It gives a lot of opportunity to the tier one suppliers uh, to hone our development skills. And as Yuji-san said, that removing the mudas. So, in fact, you will be surprised to see that the same product which we used to develop in 3 years' time, and we used to fill in the gaps. Every activity will take some time, and there will be some other activities in between. Now, the same product we are developing in less than 1 year's time, with the use of multiple tools available, like simulation tools and those rapid prototyping tools and all. And this has actually reduced the overall cycle time of development. For sure, Panda-san's demand is always have been to further reduce it, but then I think it's a continuous cycle. We believe that there will be a time when we will get one request from Panda-san, and then next week we will be there with the product with a complete development.
So if you look at, I'm really happy to accept and applaud the industry also for that. Look at the cost of vehicles and versus features that we have right now. There has been a very huge jump in the kind of features we are offering and the kind of cost increase we have seen, or the price increase for a customer like us. So for this, I think automotive industry is one of the industry that has maintained a very low price hike in terms of product versus the value and the features that we are getting. So many congratulations on this to entire value chain. Coming back to again, the value chain, there are some missing links, especially the small component manufacturers. They do not have appetite to invest in technology that much. How are you hand holding them to adopt this technology? Is there some kind of sharing of technology happening between tier one OEMs and tier two and tier three? Panda-san, a brief answer from all of you in just few seconds, because we have already gone 1 hour on the session.
A very quick response to this one. At Maruti, we have our supply chain, our quality assurance and engineering working with our partners. And we have various methodologies of how to how to share our thoughts, our knowledge, and our expectations with our partners, and they in turn, and of course we whatever we know about manufacturing or about technology or about quality assurance, we share with them, and then we expect them also to share it further with their partners. Down the value chain, unless everyone becomes aligned with the thinking of good quality, good production, removing of muda, innovation or kaizens, till the time down the line we have this education happening, we learn, we teach. I mean, each one teach one sort of thing. It happens in the industry also. Only then we feel that we can get the benefit, and to our to our credit of our partners, all of them are so responsible that they have taken care of their T2s and T3s to get them to do the right investments, to put in the right machinery, to put in the right people, the processes, because of which the overall quality of the product which goes to the customers remains good.
Thank you, Mr. Panda. So, because the time
That's
is
all
very
from me.
less, yeah, time is very less. So, I'll directly come to my last question, and this is to you, Mr. Pereira. We are talking about Industry 4.0. We are talking about blockchain. We are talking about AI in automotive industry. How much of it is really reflecting on the results when we manufacture, or we talk about manufacturing of automotive component, be it vehicle in your company, in your industry, or when do we see substantial, substantial, result coming by way of use of blockchain or Industry 4.0 that we are talking about, or AI, artificial intelligence in manufacturing?
I think we are not far away. In my honest opinion, I think in the next 1 to 2 years, all OEMs will start to see benefits of evolving technologies. But in order for us to do that, maybe on what Mr. Panda also added earlier, the entire value chain has to work from your tier 1 to tier 2 to tier 3, right? And
Do you think R&D and product design and development is going to be one of the largest beneficiary of these technologies?
absolutely, I do. And I think that co-creation mechanism is what's going to benefit this. So, but if you do also ask me to look at blockchain per se, it's still not widely used, nor have we seen the capabilities that blockchain can bring onto R&D specifically. So I think in this era, with more evolving technologies coming and collaboration happening, we have also reached out to our suppliers to work together, because funding is less. Everybody's in a difficult situation. So can we work together in a partnership to bring these technologies that can not only benefit us, but also the entire value chain? So I think if we work together in that sense, we can realize the benefits of this. And again, in 1 to 2 years, you will see results.
Thank you, Mr. Pereira. Before I start taking questions from the audience, I'll give the opportunity to the panel also. So next 10 minutes, I'll dedicate for the panel members to ask questions from their co-panelists. So over to you. Anybody can raise their hand and point the question to any of the co-panelists.
Yeah, just one question to Panda Ji and Charanga Ji, yeah, OEM. So yeah, it's important to work together at OEM tier 1, tier 2, tier 3. So maybe I think do you have an idea to share the OEM strategy more openly for the future development?
It's a difficult question.
Sorry, I could not get the question. The OEM?
Yeah. So do you have what is a development roadmap? Because
Okay.
we need to know the OEM trend so that we can cooperate, work together efficiently.
Very interesting question, and I all of we address this in our own manner. Every company has a different way of addressing this. Some of the companies, they address it when they have a annual conference and with their supplier partners. They give a broad direction about where they are going, how they are going, and then they work with specific partners to develop technology. So certainly, we would also like to follow similar methodology here, and I'm sure that we'll find good opportunities to work together. Pereira, if you want to add something.
Yeah, Mr. Panda and Yamamoto-san, I think, yes, we are very much open, and now more than ever before, because again, co-creation is something we really believe in Daimler. One is we sometimes only look at ourselves and our problems, but there might be a better solution outside that can not only solve our problems, but someone else. So I think right now the direction is partner more, co-create more, so that it's mutually benefiting to all of us. So I will just speak from a technology standpoint. I think we are looking very much to partner with anybody who's willing to work. So, put your skin in the game and make sure that we all benefit from it. So it's a win-win situation, and then the entire ecosystem involved. So we're definitely open.
Yeah, thank you for your answers.
Thank you. If I'm allowed, I can ask one question as a co-panelist now. Mr. Panda, looking at the current situation, like a focus for health-related features must have increased for the OEMs. Can you give us some understanding which are the features that we may look forward to in a car going forward? And that you can give a clue to the suppliers also to be ready.
Coming to the current situation where you are having COVID and where hygiene and social distancing are supposed to be our main weapons against this particular issue, here more than innovation in the product, the innovation in the process is important. So when you are going to say deliver the or you are taking the car for service, how can you ensure the safety of the customer and how can you put your mind at ease? That's what is going to matter more. And that is where perhaps all the manufacturers and also Maruti we are focusing on and ensure that we give people that assurance by using various technologies. In fact, even while selling the car, I think nowadays you'll find that the bookings being done digitally are more than walk-ins. So people are also embracing the virtual world for procurement of cars. When we make cars, uh, car making is a manually intensive process in the assembly line. But there also we have to ensure that we have adequate social distance of about 6 feet, because of which we have innovated on our line as to which process has to. That is the kind of innovation we have done. And perhaps more than the product, I think the process of making and selling, buying of cars, which innovated in this particular era.
Now I'd like to open the questions from the audience. So I'll take the first question, obviously about electric vehicle. After COVID came in, a lot of talk has happened that electric vehicles may take back seats. And I would like to take an opinion from the component suppliers because they are the backbone. If some products are coming, they're the first guys to start developing the components. Do you think the electric vehicles has really taken a backseat? Vivek and Yuji, and also Mr. Panda, if you could contribute to that.
So Nabil, I think since you took my name first, I'll go first.
Yeah.
I think yes, that's very right. That maybe the electric vehicle has taken a backseat, but how much back is something which we have to see.
Have you got any order cancellation or delay from any of the OEMs? Don't take the name, just give us a sense.
Yes, so there are certain development products which have been deferred and thankfully not cancelled, but deferred. what happens, Nabil, is that
So this difference is for how long? For how long it has been different?
about 6 months to 1 year. 6 months to 1 year is the cycle which is there. So
Okay.
the memory the memory of human mind is very short. So if this COVID-19 has to end maybe in next 4, 5, 6 months, as the all optimistic people are saying, then probably it will not make much of the difference, and will come back very quickly.
Okay.
Otherwise, it is going to be taking a bit longer backseat. I think so.
Thank you. You gave a very clear answer. Yuji, your thoughts. Have your orders also been for electric vehicles been cancelled or deferred, and how much? Just short answer.
So we are working for electric vehicle thermal systems, including a powertrain and also cabin. So what is important is software development, how to control. Okay, for that, as Murari-san said, model-based development. This is we can take the much more standardization. Yeah. So that we can take the variation.
My question was, have you seen deferment in the electric vehicle supply, that the order that you got?
Performance?
No, deferment in delay in the electric vehicle project. You have witnessed, right?
Yes, I think so. But taking this time, yeah, my point was try to standardize using a more efficient way, because yeah, so not hasting, but we can have a chance to have a time to develop a standardized way for the new EV.
Mr. Panda, what could be the possible reason for this deferment of electric vehicles, and why has it taken backseat? Because you are an OEM.
If there are any deferments on people's what you call roadmaps. However, one thing is for sure. See, currently the electric vehicle costs are very high, and the affordability of the customers is not to that extent. So maybe it's a blessing in disguise for everyone in the sense that if people get sufficient time, they can work on the cost and make it more affordable for the customer. The customer also wins in the process.
So next question is Mr. Panda and Mr. Yuji Yamamoto or Vivek. All of you can contribute, but very briefly, because we are running out of time. Is there any initiative in terms of organic friendly material used in vehicles, recyclable, biodegradable materials in EV and ICE vehicles? Start with Mr. Panda.
Recyclable materials, organic materials, all these come under efforts towards sustainability. If you look at our country's biggest issue is that we import almost 90% of the energy that we consume in terms of fuel. So if we can find ways in reducing this by using renewables or by using energy sources which are more abundantly available, are cleaner, for example, compressed natural gas, which people are not using much. If we can do that, then that will help not only the exchequer, but also the environment, but also the customers to a large extent. So from that point of view, I feel that we should be going by what is the area where you want to focus on.
And I think we are also working on increasing the use of recyclable material in vehicles, right? With scrappage policy coming up.
Yes, in fact, even in the country, already the scrappage policy is going to be a reality, and recycling is going to be reality. We are also, as Maruti, we have also started our own what do you call method of doing this recycling. So it is need of the hour that you have a recycling methodology and process for the automotive industry, and you have some sort of a scrappage policy so that the old vehicles which are there on the road, which are say very fuel guzzling or are heavy on the pocket of the customers, they get phased out and they get replaced by more fuel efficient vehicles.
Next question is for Vivek. Would current situation lead to minimize the development process, such as time of test milestones? How we will cope up with such a thing, especially for critical parts like steering, chassis, and suspension?
I think this question is perhaps coming in from the point of view of that whatever time has gone because of COVID-19, it's a lost time. I would not approach it in this way. I think the testing cycles in the automotive vehicle, it's not very easy to reduce in such a short period. It needs a lot of discussions and deliberations and perhaps simulations to find out a shorter way of doing the testing. And I hope that panelists will agree with me that the critical items like the steering and the items which are related to safety, certain amount of testing on the actual product, we have yet to find a simulation only for that. So ultimately, this will help. Simulation might help in reaching to a certain level of design, but once the design is done and a proto is prepared, it has to go through a certain cycle of testing. So cycles might get reduced by way of using the latest technologies in simulation, but I don't expect it to become zero or become too short. Whatever is within the visible future. This is my take on this.
Murli, you want to add?
Yeah, I think a few things I think.
Briefly, please, because we have less time.
Yeah, I'll just touch upon you. You mentioned about the new materials and so on. And this is where I was just talking about regulatory compliance. And I said integrated program approach for the OEMs or for large tier 1 suppliers. In terms of the material that you use, again, right from the word go, when the program is launched in, there is a need for tracking. It's not as if at the end of the cycle you do so. And to the same point that Vivek also talked about, and I think Pandasan mentioned that, it's not as if we want to eliminate testing, but how do we make the process more efficient? The money and time and resource that we employ in testing also gives us the returns for what we do. So to that extent, to make that process efficient, if the upfront front loading is done in terms of the whatever we can simulate, it's not to eliminate testing. We certainly need to validate, and also, of course, there are compliance requirements. Before we launch the products to go through testing. So there are ways of tracking that, and in my view, I think Sringa also mentioned that we can't have islands of excellence. It's got to be a sort of a backbone for the whole collaboration, backbone for the whole design and development, where each of the stakeholders, whether they are from part of the design, whether they are testing, whether they are simulation, whether they are quality inspection, they need to come onto that integrated backbone, and that's where I think the whole value addition happens. Is my quick take.
What do you think about the importance and need for self-reliance and independence in R&D for JV companies like yourself in COVID situation?
Well, I think Nabil, JV companies, which we are also a part of it, is self-reliance is very important, especially in terms of technology, be it COVID or be it not the COVID situation. However, I think going forward, we have come a long way. Most of the companies which are in joint venture now in India, and we're not anymore zero technology and only build to print companies. Most of us. I think the time has come and we should move from independence in technology to interdependence with the partner overseas. So we have to create our capabilities so that both can complement each other. I think everybody will agree with me that there is a need for augmenting our own capability in terms of simulation, in terms of testing, in terms of designing and supporting our OEMs. But no more the singularity that I do everything should work anymore. It should be now we should be on an equal platform, and we should be dependent on each other rather than going completely independent.
So I have 2 minutes left, so I'll take one last final question, and I would need the answer from everybody. Brief. Sir, we are talking about going vocal for local, creating a local supply chain, robust supply chain. We are talking about localizing engineering, R&D, and everything. What are your thoughts when the government has almost cut the incentive for R&D? We used to get 200% weighted deduction on R&D. Now it has been made zero. So what are your thoughts on this? I will start with Mr. Panda, then everybody can join with their thoughts. Is it
Well,
important
since
that
the
the
world,
government also, is it important that the government should do all the time handholding? Because the industry's R&D spend is still at less than 1% on average, if you see.
see, first of all, there are a few things that we have to get into perspective. Indian automotive industry started growing sometime in the 90s. 85, in 1984, in fact, I think the entire country sold about 50,000 cars. And in 1985, R.C. Bhargav at that time made a statement saying that Maruti will make 1 lakh cars. Almost all the people, they especially the media, were not what do you call, they felt it was not, it was an incredible statement to that you'll make 1 lakh cars in a country where you have only 50,000 cars being sold. But today you look at the number of cars and number of two-wheelers which are sold in. So one of the reasons I feel that the country could have so much of penetration of cars, prosperity in terms of GDP, was primarily because we embraced the concept of localization. Earlier, localization was embraced in terms of manufacturing. Second part of localization wave is of what we call designing, and I think this is the activity for which the time has come, and market is ripe, customers are there. So it is time that all of us have to start innovating in India and making it.
I guess I just want to make a last point. There was a lot of discussion on the product life cycle, time to launch, and so on. All of us are happy when the life expectancy goes up, but only in the automotive product space, when the life actually reduces, we we probably are feeling happy because we have brought out something worthwhile. So with that said, what we see is again, I will keep this focus for OEMs and the large system suppliers. The options have increased manifold. But, whichever product is on a certain base architecture, the variants and options are pretty high. So what we see is a very strong move towards modularization. How do I make more from whatever development costs have already been incurred? I think Vivek mentioned that to make each program profitable as well. So what we put in, whether it is the OEMs or the suppliers, there needs to be the return on the capital employed. To that extent, what we see, at least in the last 6-8 months, is there are very complex problems. If you take the bill of material for large number of variants, how do you handle the technology? It's not an easy problem with the colors and variants and so on for each one of them, at least for the OEMs. So what we see is a very strong move towards modularization, just so that the development cost is sort of compartmentalized and you're able to leverage the work which is done, the products which are already used in. We see that as a major thing that's coming in, and we see again, Pandasan mentioned that it's not just about innovation in the product per se. It is also the process that we follow in developing the product or manufacturing the product. There also there's a lot of innovation, which I believe there are possibilities that presents itself, and now is probably the time to take advantage and bring those basic, what we see as basic disciplines. I'm sure we can absorb that and put that in his my submission.
Thank you so much, everyone, for joining in ET Auto Live panel discussion today. I'm sure you guys have been able to answer several rising questions that has come in the time of crisis like this. Up next is stay tuned for a presentation by Mr. Ramamurthy Ayyappan. He's technical director at Siemens. He's going to give a in-depth presentation on what are the alternative, to drive innovation in terms of product design and development in automotive industry in current situation. What can you opt? That's a presentation will be coming up next. I would also like to invite all the viewers to join in our next leadership discussion on June 4th, which will be on ET Auto, and this is going to be on smart manufacturing and also how to build a robust supply chain, value chain in India specific to automotive industry. All the top leaders from the automotive industry will be joining on June 4th at ET Auto, same time. Once again, thank you so much, everyone, all the panel members who have joined in today and shared the wisdom and the answers, the pertinent answers to the questions amidst new normal where we are living in. Thank you so much once again, gentlemen, for joining the Auto Live panel.
So thanks a lot, Nabil, and for the panelists. So look at how do we drive the innovations and what is the future of design and development, and including the product and process on the manufacturing side as well. So we see that the digitalization has changed everything. So rather than a physical event, we are having a virtual event, and there are a lot of things, the way in which we buy, communicate with each other, the way we travel, which is now becoming more complex. And there's a lot of the big data, IoT, laser scanning, AR and VR, the AGV, robotics, artificial intelligence, a lot of technologies which are there. And we also see that the Industry 4.0 is driving this, and the digitalization is actually powering the Industry 4.0. So that's basically from the overall industry perspective. And we also saw more about from the automotive side of it, where we're looking at more autonomous electric and mobility, which the vehicles are connected, vehicles are electrified, and more autonomous in nature. And then when you look at the process side of it, how do we take back the information from the field, from the plant, from the vehicles which are there, from the users who are using the vehicles, and put back into the design side and the development side of it, where we call it as a digital twin, where you're able to pull back this data and make this digital twin more high fidelity model. So in a way where you're able to have the model behave more realistic, to have a mimic of the reality. And for that, the systems engineering becomes really a big, plays a very big role in the future of mobility. So let's start with the autonomous driving. Say, if you look at the ADAS, which there are most of the companies are already on, and you see on the SAE side of it, there are multiple levels of it. We have the driver safety, pedestrian safety, and we have completely autonomous at the level 5. And if you look at the testing which are required, it is going to be in millions of kilometers that you have to do that before you can actually put the vehicle on road. And there are currently about 100 cities who have allowed the testing of the autonomous vehicles. But if you have to really make it production worthy, then you have to run millions of kilometers, which then really becomes practically impossible to launch vehicles. Then it puts up a huge pressure. Now, how do you bring all this virtually? And then how you create the regulations so that you are able to validate it and then approve this and get it certified. And now you look at 5G, you have the traffic sensors, the vehicle has to look at the traffic lights, look at the people who are there, the occupants, occupant safety, so on and so forth. And this involves a huge amount of simulation and testing. Now, how do you make that digital, and what are the tools which are available, and how the process you are looking at in terms of going in from the ADAS to the autonomous side of it. Now, if you take one step further, now if you are making a complex system, maybe on the autonomous side or on the electrification or mobility, we already talk about the amount of software, the amount of increase in the software which we have, and how it needs to connect to the vehicle, connect to the servers, and also increase in terms of the electrical and electronic and the mechanical content, and the need for the virtual validation and verification. So the digitalization needs to be start integrated and stay integrated so that you are able to have what we call as the continuous digital thread. So the digital thread is where you are able to take it from the requirements, looking on the functional parameters, and then break down into the functional areas, and you have the connected engineering, and you're able to digitally simulate and validate, and then you are able to launch it, and you're able to bring this data back into your systems for the continuous improvement. So we see that there is a huge level of improvement when you're able to bring the electronics design and the mechanical design together. And traditionally, these were actually happening in parallel in silos where the ECAD engineers were able to do certain things on their own. There is powertrain engineers who are working, and then there is body and structures, chassis, who are working in different silos. And where when the physical prototype is there and you're able to test it, then you see the problems and then go back into the design and development. But how do you able to bring that at the design stage itself in terms of integrated design? And when you look at the holistic digital twin, where you are able to bring all these aspects of it together into the digital twin. So you have the market requirements, you have the model-based systems engineering, the CAD model, the MCAD model, you have the ECAD model, the electronics, the software, and then the CAE side of it where you are doing the thermal fatigue, the CFD analysis, and so on and so forth, where all this information are brought together, and this becomes a holistic twin. So it does not only look and feel like a model, but behave like the digital twin, so that you are able to have a model which is a high fidelity model. And to make the scenario more complex, now you have to do that for number of variants. Talked about increase in personalization, increase in the amount of vehicle, the personalized vehicles or configured vehicles which are demanded by the market. Now, how do you ensure that you are creating a program and work for all these kind of vehicles? So you have a different program for each kind of vehicle. You have to have this software integrated with the PCB. PCB needs to connect with the mechanical systems and the electronic systems, and all these things need to work together. And then you add the complexity from the manufacturing side, where you have alternate parts, substitute parts, and then you have the color bomb and things like that. Then becomes a really huge scenario where you need to manage to get into this new world. Now, putting it all together, how do you ensure that you are able to connect all these in a digital thread? So bringing in from the market requirements, creating the models, which are the electronic as well as the mechanical and the software models, and the test case parameters. What are the scenarios that needs to be tested? How it needs to get validated? How do you certify it? And then the physical side of it. And then there goes the calibration. So you're able to calibrate with the test models. So you need to put that scenario back into the digital models so that the amount of times you're able to validate, optimize, is a huge amount of possibility of optimization when you're able to have this digital twin. So this gives the huge amount of potential to actually make this overall development process much more optimized, and you have a full process traceability. Full process traceability from the design to the development and into the manufacturing to the delivery of the vehicles to the customers, and then you have the compliance and the other scenarios as logs always available, so you can completely track each and every aspect of your product development. Now you take that development, you also need to manage this. We talked about the program management. So what are the stages? You need to compress the program management from the 2 years to 1 year and further. Then you need to know that on a real-time basis where we are working, how we are working, and what needs to be improved on, and so on and so forth. While we are working on all these areas, how do you ensure that the vehicles we are making money, as well as it is profitable both for the OEM as well as for the suppliers? So we have the concepts of you find out the profitability. How do you do a target costing or a design to cost? How do you do purchase price analysis, the tool costing, and open book negotiations, and so on? So how do you ensure that you are able to identify the cost drivers and then look at what are the possibilities that you are able to minimize and eliminate it? Say, for example, you want to compare with, if you're a supplier, you want to compare with supplier A, supplier B, supplying from 2 different locations or from different geographies altogether. So how do you compare yourself, like when you are in a global market? Now you can also look at from a manufacturing perspective. So you're looking at products and what are the critical to quality parameters. So how I can minimize my cost, so I can improve my process so that I'm able to supply the parts at a high quality at a much competitive rate. So how are you able to do that? And then you are looking at a high level of strict cost management. So you know that whether you're making this product, you're profitable, how much you're profitable, and if the scenario changes, for example, the material price changes or the volume changes, how are you able to react to these changes becomes a critical aspect for the OEMs as well as for the supply. Now, with the change, on the additive manufacturing, we also saw, as a part of the Industry 4.0 drivers, there's a lot of focus on the additive manufacturing. Now, the traditional parts which are there, if you see the one which is on the top left, the parts which are typically designed in such a way. Now you look at when you are moving towards the generative design. So generative design is more about how the designs can be more bionic in nature or more natural in nature, where you provide the constraints in this case, which means it needs to link point A and point B. It needs to have so much of strength, and it needs to clear off these many areas and needs to get assembled. Now you can drive the software to look at how the part can be generated, what can be designed by the software, and also how it can be manufactured. So in this case, you want to have a printed part or the traditional way in which you want to manufacture. You can put those constraints, and now you have a part which is probably 30 to 40% weighing less compared to your traditional part, and there are possibilities where you are able to combine 5 different parts or 6 different parts into a single part. For example, Siemens, one of the fuel nozzle that we have done, more than 12 parts have been combined and we have made into a single part, where it would be a huge improvement in terms of both performance as well as in terms of time in which you're able to make these parts. Taking this further into the development side of it, so where it's the additive manufacturing coming inside, and you have the shop floor more flexible in nature, where today you have a high level of automation, but then most of these are fixed automation, means it is manufacturing for a particular or a B particular kind of parts. Now you have the scenario as a supplier or as a OEM where the parts are completely flexible, which means each part which is coming on the line can be different. Now the AGVs need to know that which part needs to be supplied to which location, what operation is to be performed, and the need for the scanners and the real-time location systems are critical. How we are going to imagine this scenario and create this digital twin so that you are able to create a completely flexible product in your factories. Having said that, you can also make the plant digital. You can bring these scan data into the digital model, so you can have a hybrid kind of scenario. So you can scan your factory, your layout, and bring the new parts. What are the changes you would like to do in the layout? So you have some amount of parts which are there in the plant, which is actually running. And then the changes, say there's a new product which needs to be introduced. So the product is new, but the plant is the current plant, and there can be a new level of automation which needs to be there. So you can bring those things, and you can have digitize the brownfield data so that you're able to have a launch which is much shorter than the traditional way we look at launching the product. We also talked about the customer experience. So more people are logging in online and booking the vehicles. So how do you give a complete rich experience with the virtual reality? So pockets of individual sitting at home or at kiosks where you're able to virtually sit in the car, you change the colors and the upholstery and things like that. So you ensure that what exactly is required by the particular customer and how do you configure it for increase of business. And also looking at the augmented reality, where this can be used for training the operators in the shop floor, or the customer service maybe at different location where the guided customer service can be done using the augmented reality scenarios as well. On the advanced robotics, so more AGVs are coming in. Now, how do you put all these, automation and the flexibility? So you cannot have all these things, put it on the shop floor and imagine that the shop floor is going to work with it. So you have to plan that. So what kind of equipment, what kind of robots and AGVs are required, how it is going to work, how this scenario is going to, multiple kind of scenarios are going to be running inside the shop floor when product changes, the product mix changes, the volume changes, and so on. So how do you ensure that all these scenarios are virtually validated and you are connecting into the shop? And with the new social distancing coming in, so how do you simulate, rather than having the shop floor work and the workers' safety being at risk. Now you can see that on the right hand side, the workers are operating. There is a circle which is there. You can keep it 1.5 meters or the distance specified by the government. But as a normal process, you see there is a lot of red spots which are there. There is a possibility of the people coming close to each other, and there is a risk. Now, how do you ensure that this kind of situation can be avoided? How do you rebalance the work? How do you rebalance the activities? How do you work with multiple workers? How do you ramp up and ramp down depending on the demand? So those kind of things are simulated digitally so that you have a first time right, in terms of the shop floor, and also look at the operator safety in terms of economics and the kind of activities that the operator is going to do on the shop floor. And the need for virtual validation in terms of quality. So how do you produce parts digitally? So you have 1,000 parts producing in a shift. So can you produce that digitally and also look at what are all the critical to quality parameters? How do you inspect this data from all these devices? Close loop back and identify that how well you are producing, and then improve on in terms of what are the areas need to be which are identified. So there's the amount of huge data which is there, or the inspected data. But how do you make sense out of this data? How do you do what you call as the principal component analysis and different kind of analysis so that you are able to improve on your product quality. Taking it further, how do you take this information from the plant IoT, bringing the data from the shop floor, look for predictive maintenance, and also have the same IoT coming into the connected vehicles where they're able to pick this data from the vehicles which are there, either autonomous and electric or a normal connected vehicle, to actually bring this data and use this information across. Now you see that how the heating happens in your brake pad, or the how the climate control works if the number of passengers are more, what is different kind of passengers who are there at varied time period. How do you optimize all these scenarios? Now you can actually bring this data from the field and you're able to analyze it and create your product development much more richer, much more optimized. Now with the new scenario with COVID, people are working from home. How do you ensure that you allow the business continuity, but also ensure that there is no misuse or your IP and the data is protected? Say for example, you have the design data and the information is there at home. There's always risk associated with the data. Now with the digital rights management, you actually have protection where the data is protected on the move. Earlier, the data protection happens only when you have within the campus or within the premise of the office. Now the data is protected within inside the data itself. So which means even if the data is taken away or by the competitor or something, now you have the data which is completely protected. Now you know that nobody can do anything with the data, and you can completely trace if there are any kind of mischief which is happening, because all these are logs and that get connected to the server system, and the information is immediately passed on to have any kind of if there is any possibility of breach, so on and so forth, in case it happens. So you have a complete traceability: who's using, when he is using, how much time he is using this data, and what purpose, whether he's authorized to do it, not authorized to do it. All aspects are there, and you can also take to a level where what he can do with that data. Can he modify it? Can he change it? Can he print it? So on and so forth. Every aspect of this data is now you can be protected with the digital rights management. So as an overall digital enterprise, you are looking at the digital twin of the product, digital twin of production, and the digital twin of performance, with all these new technologies on the machine learning, IoT, big data, AR, VR, augmented reality, virtual reality, autonomous robots. So how do you bring all this? How do you put that in the automotive context? And then how do you ensure that you're able to create a platform which is continuously improving and with the industrial security in place? So that's basically we'd like to summarize on the Siemens vision, on the areas, on the technologies which are there available. Now, what I will do next is take it further to the demonstration side of it, and if there are any questions, I would like to take that. Otherwise, I go further and do the demonstration of each of this, whatever we saw a few minutes back. Now, we saw with the digital twin where you have the virtual product, virtual production, and the real production and the real product, all things connected across seamlessly and able to communicate, create a digital twin of each of the system and collaborate with each other. Now let me go into the digital twin of product. So look at each of these areas. What you can see from the area of design, where there are advances which are there in terms of industrial design and styling, and also bring all these parts in a secured and collaborative environment with Team Center. And all these are connected with the CAE, so which means that you have your engineering, the design information, as well as the CAE engineers are working collaboratively. So you know that what is the CAD data. Now you can take the representation of the CAD and you can create your CAE data for the pre-processing, and you can create multiple sets of things. Say for example, for structural analysis, for model-based systems engineering, or for a CFD analysis, and there is link with the product data as well. Now you know that the product changes. Now what are the areas it gets impacted across in the CAE, and have a collaborative authoring, so ensuring that there is no mismatch between the design and the CAE, and it can also take it forward to the testing side as well. So earlier we looked at it from a CFD perspective, so you can also look at it from the structural analysis aspect of it as well. Now the advantage is, the automation can be done into the process, which means these are the products which are there, what kind of patterns in which you would like to have your simulation done. So the simulation pre-processing can be done in a batch mode as well. And the area we looked at, how do you ensure that you are able to work on an environment where the mechanical and the electrical engineers are working together, and also looking at optimization of the combined system. So now you have a system where you have the parts, you have the mechanical parts and the electronic parts. Now all these are working together, and you can drive look at how the thermal performance of this product, to ensure that the product is reliable when put on field. How do you ensure that you are able to test this scenario? Now this test condition can be taken as a digital twin, so that there is a calibration between the test and the digital twin which is there, to ensure that you are able to optimize this scenarios, so that your digital twin is capable of simulating the real test conditions as well. Now that can be taken in for your motors. It can be taken in for your the electronics systems as well, in terms of both in electronics design as well as your CAE analysis. And also you look at the autonomous. So look at multiple scenarios. So how the lane change is going to happen. So the scenarios, how the pedestrian safety, or looking at scenarios where the automatic parking assistance need to be provided. So you need to have all this, combined sensors need to come from multiple sources, possibly coming in from the 5G as well. So you have the vision cameras which are there, need to identify the pedestrian. So there is more amount of machine intelligence which needs to be built in terms of whether the object is a human or an animal, or the conditions need to be simulated, whether it is a rainy condition or there is a mist which is there. So at hot conditions, so all these conditions need to be simulated, and that puts a huge pressure on your programming. Now how do you bring the programming environment into picture and create the product which are connected, and you are able to test for the specific scenarios, connecting the software as well as your sensors and the electronics working. Now you can also look at how do you look at the electric vehicles in terms of creating the battery performance, the thermal scenarios of the battery. The systems engineering is working together in terms of how do you put it together as a complete vehicle, and simulate the scenario as what we call as the model in loop, software in loop scenarios as well. As it works together, how do you create products which can also have a possibility of the additive working together on the areas. There are possibilities where some of the product which need to have a service scenario, rather than having spare parts being spent. Now you're able to print these parts and send it across over the email. So how do you ensure these kind of possibilities exist when you are looking at a service condition as well? Now if you look at these scenario, so let me move further, and from the product design into the digital twin of production. So in the digital twin of production, you look at how do you plan the environment. Say, for example, I'm doing the planning for my electric vehicle. So how do you create your manufacturing bill of material from the engineering bill of material? How do you select the right configuration? and then create the alternate parts and substitute parts and so on. So you're able to create right product, and that is you can actually do a reconciliation between the product which is configured and the product which is going in for the production, and creating the digital layout. So you have the plant is completely available. The digital twin of the plant is available, and every aspect of the plant, you're able to connect it across to the shop floor, so you can actually look at mimic the real world performance as well. And you can run the production. So look at how many people are there. So you have the scenarios where the production there's increase, there's a dynamic change in the volumes which are there. So every day, if the production volume changes, you need to look at how many people are required. How do you rebalance the work? How do you rebalance the activities? How do you maximize the output? What kind of shift patterns you look at? And also look at staggered shifts, so that there is minimal issues in terms of people going into the canteen and so on, where you can prevent the social distancing happening in those scenarios as well. So how do you optimize, simulate and optimize the process? In this case, how the battery pack is assembled into the vehicle, and each of this scenario you can actually simulate it. You can also commission it together, which means the actual PLC program which is driving on the shop floor. Now the same PLC program you can actually drive the digital factory as well. And case where you are printing some of these parts, so how do you maximize the printing capacity? So what are the parts which are there? How much I can accommodate in the single print? How do you validate this? How do you ensure that these prints come out? I claim maximum productivity out of my printing, 3D printing, which is there on the shop floor, to ensure that how much I can do in a single setup. And ensuring that all these things are connected with the shop floor SCADA systems and the PLC systems as well. So it's not just there on the virtual side, but you're able to connect it across to the CNC machines, the PLC programs, and the automations which are there on the shop floor. Now, you can also drive the programs which are there running the CNC machines. Now, this basically simulates what happens on the digital side of digital twin of production. And you move further into the digital twin of performance, where you can actually whatever is planned, you are executing how you schedule your production, and the scheduled production is simulated across into your multiple factories, multiple areas of the factories, either in the sub-assembly, kitting, machining center, or in the final assembly. How you are able to distribute this work, ensuring that the order is timely fulfilled. And also ensure that there is complete traceability. So that there are serialized regulations which are there for safety related parts need to have a complete traceability. So you have each parts which are serialized, which are connected to the vehicles. So you're able to know that what time, which supplier, when it was done, who's the operator. Every aspect of it is completely traceable. Now you can also look at how the overall scenario as the production happens. Look at what are the products which are produced by equipment, by operator, by shift pattern. So multiple levels you are able to do that, and also produce not just mechanical, but there is more electronics coming inside. Now, how do you produce the PCB assemblies which are there? So you need the SMT lines, either from a OEM or from a supplier side of it. So how do you bring these PCB across? There's more IP into it. How do you program for it, and how do you balance the line of the PCB assemblies, and bring together with the shop floor vision systems and communication systems and the AGVs which are there, which are also protected by the industrial security, and the amount of AGVs. How do you program for this? How do you ensure that the twin and the physical AGVs connect together, ensuring that the production is optimized, and the real-time locating systems to ensure that where each parts are located. So there is a level of complete visibility in terms of the inventory as well as the parts. You can track the inventory as well as the people, as well as the material handling, and also when the new communication systems of the wireless LAN and the 5G comes, how do you work with this? And also bring the IoT side of it, where the machines picking up this data, sending it to the connecting it to the what we call as the Mind Connect. So through this data, where you are completely monitoring your machines and also looking at improving the performance of these machines and performance of any other kind of equipment as well. So in this case, you're looking at how it is doing the printing, and also at the level where you are able to do automation and how you're able to run through the machines more effective way. And from the automotive side, how you are also connect with the e-car charging components as well, and ensuring that your machines and equipments at the shop floor, you have a mechanism to improve your productivity, and all this comes with the motion control services and the predictive performance of your field services and equipments as well. So looking at all these scenario putting together, where you're able to run through this digital twin, where digital twin of production and the performance and the actual field performance from the real production as well as the real product, you are taking it back into the virtual product and the virtual production to drive the continuous improvement, which basically is the future of the design and manufacturing as we see from the Siemens side of it. So with this, I would like to open for questions. Moving back to Nabil and the auto team.
Yeah, so I have a few questions, but there's Mr. Aniket Bag. He wants to get an answer. He's from automotive engineering service provider. Will conventional design and analysis CAD CAE activities will be reduced and AR VR technology service will increase? What's your view on this?
Okay, so the idea is there is still a requirement of the products being created. So you need for the VR and AR to work. For the VR, you have completely everything is in the virtual world, where you need all these products to be created in the design. So you need a CAD to do that. Now, the way how the CAD operates, there are changes which are there. Earlier, you used to have everything. You have to create create a and do extrude, protrude, and all these operations to create a part. Now you have more automation into it, which means that, okay, I need a part which needs to fit across. It needs to be approximately of this shape. It needs to connect these two devices. It needs to have so much of strength and rigidity, and then you can actually give it to the software so that the software creates a design which meets your requirements. So in a way, the software is there, but it is now becoming more intelligent. But then it becomes a requirement for the VR and definitely for the AR as well, because you need to augment it with what you are looking at from the shop floor. So the need for CAD now has increased because of with this possibility. So in a way, it is actually more. But there are more tools which are there to bring it to make it more easier. So, for example, earlier I talked about the software designing, but you can also have a scan where you can actually scan the physical objects, and you can take the scan and then play with this, massage this data, and have a quickly create another part which is today possible, which was probably was much more difficult in the earlier times.
I'll take last question in the interest of time. What innovations can we see in research regarding user-consumer feedback to initiate product design?
So the product design, right from the user feedback. So the user can be your customer or the final end customer as well. So it can be multiple scenarios as well. So the look and feel of the scenario, for example, wherever the consumer touches and feels. So in terms of either it is the steering wheel or the gear shift pattern, the level at which they reach at which he is going to do. So for example, you can have you cannot put the same vehicle which is there in Europe and put it there in India, because the what we call as our anthropometric data is very different from, say, maybe a German, which possibly the size may be very different. Now you have probably Indian female 50 percentile, female 5 percentile female. You need to have specific requirements for this. How do you take those requirements into place? Then that becomes a huge possibility where you can actually capture these requirements and create personalized products, which becomes we talked about the more configurable products. Now it becomes a lot more possible with the personalized products for specific, say, there is a disability or personal preference over a certain aspect of it. Now you can actually take that information back and create these products, because now you can capture the human preferences. For example, the same thing is taken across for say knee replacement. Now you have a problem in the knee, and you need to have a kneecap, and that is exactly personalized. You cannot have a common generic production and put it into your knee, because the level at which the damages happen, it needs to be, it is very specific for the individual. Same way, you can actually, there in this case, you scan, take the MRI, and then do this design. We do that as well. And here in this case, we take this preference and then create a design which is user specific as well. So that's definitely possible, and the scenario is going to go more and more increase as we see these technologies.
Thank you so much, Mr. Ayappan, for such an elaborate and insightful presentation. And I thank the audience for joining in ET Auto Live panel discussion. I would like to apprise you that ET Auto is bringing all the top industry leaders on a leadership session on the topic of smart manufacturing and building local supply chain. Do join this special session on June 4th. And keep watching ET Auto, reading ET Auto, and listening to ET Auto for all kind of latest update, analysis, and knowledge only on ET Auto. Thank you so much once again.